Hello Year 7. Today we're going to do another virtual experiment using the same website that we've used in our previous ones. But before we do that, I'd just like a little recap on what you should have learnt from the last one that we did. Now, what you did was you investigated current and you measured that using a bit of equipment called an ammeter. And remember, the units were ampere. You will have made these 8 circuits, and lots of you have posted me what you found out, which was absolutely fantastic. What you should have noticed was that as you changed the number of cells in your circuit, the greater the number of cells, the greater the current. What you should have noticed as well is that as you increase the number of bulbs in a series circuit, that the current went down. However, if you had a parallel circuit, you will have noticed that the current would have increased. And this kind of ties in with what you should have learned from the first experiment that we did, where we made series and parallel circuits. You should have noticed that in a parallel circuit, the bulbs are a lot brighter than if they are in a series circuit. The one other thing that you should have noticed that it made absolutely no difference where the ammeter was placed in a series circuit. So for example, if we take circuit number 1 and we take circuit number 4, they've both got one bulb, they've both got 3 cells. The only difference is the position of the ammeter. And you should have noticed that the reading on both of those was exactly the same. So that's just a little recap on what you should have learnt from the last experiment. Today we're going to be using the same website, but this time we are going to be measuring something called potential difference. Now, potential difference is just the scientific name for the voltage. Now, the current, if you remember, is the amount of electricity flowing around a circuit. The potential difference, or the voltage, is how much push that electricity is being given around a circuit. It's measured in units called volts, and it's measured using a bit of equipment called a voltmeter. And voltmeters have got a V in a circle. Now, if we have a little look, here's our first circuit that we're going to be making. We've got one cell, we've got one bulb, and here we've got our voltmeter. Now, the important thing whenever you use a voltmeter is that voltmeters always have to be wired in parallel. Ammeters are wired in series, but voltmeters have to be wired in parallel. So let's head over to our website that we've been using. This time we need one cell. Let's add some wires like this. The wire over here. Let's add our light bulb. In it goes. Wire over here. I'll stick our final wire in. And there's our basic circuit. So if you have a look, but we've also got this voltmeter this time. So what I'm going to do over here, look, here's my voltmeter. I'm going to pull that onto my circuit. You'll notice that the voltmeter has got these little probes. So you don't actually need to add any wires. All you need to do is just to put the probes either side of the thing that you're measuring the voltage across. So I'm going to put one of the probes here. I'm going to put another of the probes over here. And there it is, look, it tells me the voltage. So I know the voltage in this circuit, the voltage across this light bulb is 9 volts. Now, if you get the wires round the wrong way, you will notice that you get a minus figure. Ooh. Okay, just ignore that. It doesn't matter which way round you've got the wires. If it says minus 9 volts, just call that 9 volts. Okay, we're going to ignore the minus numbers. Okay, so what I would like you to do, just like we've done before, I want you to build those circuits, make a note of the reading that you get on your voltmeter, and look for patterns like we've done before. What difference does changing the number of cells have? What difference does it make the number of bulbs that you have? You should notice some quite interesting patterns, especially when we start to add more than one bulb into our circuit. So what I want you to do is to just investigate, just like we did before, build the circuits, make a little note of the readings. What do you notice? What patterns can you see in your results? As ever, if you would like to post me the work that you've done, that would be absolutely amazing. I'm loving reading the stuff that you've done. And we'll talk about it next time. Okay, hope you're all well. Bye.